solve quadratic equations by completing the square. So when solving quadratic equations, we usually use factoring to solve for our variable. However, the problem with factoring is that all equations cannot be factored. So when the equation cannot be factored, then we can find the solutions to the equation by using a method known as completing the square. So when completing the square, we will change the quadratic into a perfect square, which can easily be solved with the square root property. So to complete the square, we will be searching for the third term in a trinomial. So if a quadratic is in the form of x squared plus bx plus c and a perfect square, the third term c can be easily found by the formula b over 2 squared. So the square of the half of the coefficient of the middle term b. So let's do this step by step. So this is our quadratic equation. Okay. So if the value of a here, okay, if a is equal to 1, then you can just easily readily write this quadratic equation as x squared, ax squared plus bx equals c, or x squared plus bx equals c. When a is equal to 1. So what if a is not equal to 1? So if a is not equal to 1, you just have to divide the whole equation by the value of a to make a equals 1. And then after that, we write the equation in the form of x squared plus bx equals c. Then we add b over 2 squared to both sides of the equation. So we can write it this way. So that will become x squared plus bx plus the square of the half of the middle coefficient of the middle term, and then c plus b over 2 squared. Then after that, we can factor the left side of the equation, this equation here, into a perfect square. So this equation here would become x plus b2 squared equals c plus b over 2 squared. Then we square root both sides. Then we can solve for our x. Okay, so this is just equal to that one, c plus b over 2 squared, or you can just simply write that as x equals plus minus square root of c plus b over 2 squared minus b over 2. Okay, so let's now apply this by solving some problems here. So we're given here x squared minus 3x minus 2 equals 0. So the value for our a here is already equal to 1, so we don't need to divide the equation by the value of a. So we can just write this equation directly as x squared plus bx equals c. So let's write that in that form. So this would be x squared minus 3x equals 2. And then our b here is equal to negative 3. Therefore, our b over 2 squared, which can be our c, is just negative 3 over 2 squared. So we can add b squared, b over 2 squared to both sides of the equation. Okay, so let's do that. X squared minus 3x plus negative 3 halves squared is equal to 2 plus negative 3 halves squared. Then next is we can factor this one because this is already a perfect square. So we can write this as x plus negative 3 halves squared equals 2. Negative 3 halves squared is just 9 over 4. And then we square root both sides. Okay, this would be just equal to x plus negative 3 halves equals plus minus square root of 2 plus 9 over 4. Now we can perform this one. We can add 2 and 9 over 4 by getting the LCD. A whole number added to a fraction. So this is okay, so this one would just become x minus 3 over 2, because positive times negative is just negative. So this is plus minus, our LCD is 4. So 4 divided by 1 is 4 times 2 is 8 plus 9. Okay, so this is x minus 3 halves equals plus minus square root of 17 over 4. This 17 over 4 can be written as square root of 17 over square root of 4. And square root of 4 is just equal to 2. So we can write that as plus minus square root of 17 over 2. So therefore, our answer, the value for x would be, okay, let's copy that first. X minus 3 halves equals plus minus square root of 17 plus 2. So the value for x would be, we move negative 3 halves to the right, that would become positive. So this would be 3 halves plus minus square root of 17 over 2. Since they have the same denominators, so we can just simply add them. X is equal to 3 plus minus square root of 17 over 2, or we can group them together. Okay, let's try another problem here. So we're given here 3x squared equals 2x minus 7. So the value of a here is not equal to 1. So it's equal to 3. So all we have to do is divide the equation both sides by 3 first. So let's write this equation in the form of x squared plus bx equals c first. So this would become 3x squared minus 2x, because we move 2x to the left, it will become negative, equals negative 7. Then we divide both sides by the coefficient of a, which is 3. This cancels out, so this would be x squared minus 2/3 x equals negative 7 over 3. Okay, and now let's solve this quadratic by completing the square. So let's identify our b first. The value of our b is negative 2/3. Therefore, our b over 2 squared, which is our c, is just equal to negative 2 over 3 squared. Okay, now let's add that expression to both sides of the equation. So we have 2 x squared. We have x squared minus 2/3 x plus this is over 2. Okay, plus negative 2 over 3 over 2 squared is equal to negative 7 over 3 plus negative 2 over 3 over 2 squared. Okay, then we factor this equation here on the left. Okay, let's simplify that first. So that is x squared minus 2/3 x plus negative 2/3 over 2 is just negative 2 over 6. Okay, So this is negative 2 over 6. And then we further simplify that. We can reduce negative 2 over 6 to 1/3. So that is negative 1/3 squared equals 7 over 3 plus negative 1/3 squared. So let's factor that. So this would become x plus negative 1/3 squared. This is equal to negative 7 over 3 plus 1 over 9. Okay. Let's simplify this one first so we won't be confused. So this is just x minus 1/3. Okay. That x minus 1/3 squared, because positive times negative is equal to negative. Then here we add negative 7 over 3 plus 1, 9. We get the LCD, which is 9. 9 divided by 3 is 3 times negative 7 is negative 21 plus 1. Now we get to, okay, let me delete this. Okay, so that is x minus 1/3 squared is equal to negative 21 plus 1 is negative 20 over 9, and then we get the square root of that. So a square root of both sides, so this would just be equal to x minus 1/3. Okay, this can be written as negative square root of negative 20 over square root of 9. So this would equal to square root of negative 20 over 3, because square root of 9 is 3. And now we have square root of a negative number would be equal to an imaginary number. So we can write 20 as negative 4 times 5. And 4 is a perfect square. And square root of, because we can write this as square root of negative 1 times square root of 4 times square root of 5 over 3. So square root of 1 is just equal to I. Square root of 4 is just equal to 2. And then just copy square root of 5 over 3. And we can simplify that further. Okay. So this is x minus 1/3 equals plus minus 2i square root of 5 over 3. Okay, so that will be our answer. We can simplify further by solving for our x. So x would just be equal to negative 1/3 can be moved to the right. So negative 1/3 will become positive 1/3. Then plus minus 2i square root of 5 over 3. And you can put them together. So this would just be equal to 1 plus 2 plus minus 2i square root of 5 over 3. So our x would be x equals 1 plus 2i squared of 5 over 3, or 1 minus 2i squared of 5 over 3. So that's how to solve quadratics by completing the square.